First up and leading us off is no stranger to the Water Online community and the attendees of the Virtual Water Expo. He is none other than Tom McCurdy with Aerzen. Tom, take us away.
Thank you, Travis, for that introduction. It's always great speaking with you. So today I'm going to be talking about energy efficient blowers and efficient ways to control those blowers in a fairly unique way for some wastewater treatment plants that may not even be realizing how much money that they're wasting with excess aeration and inefficient blowers. So let's get started. So this is the agenda of what we're going to be talking about today. And the first thing is a background of Aerzen, who we are. Aerzen is a blower and compressor company that's established in 1864 in the town of Aerzen, Germany. That's where it gets its name. And that factory produces all of the positive displacement products, meaning blowers, compressors, and we've also gotten involved with the high-speed turbo industry. We purchased a plant over in Korea, and that's where our high-speed turbo blowers come from. But all of those products end up in our U.S. headquarters in Coatesville, Pennsylvania, which is about an hour west of Philadelphia, very approximate. And this is where the final assembly and testing takes place if there's anything that is specific to the engineering on a particular blower package, then it happens there. And we're growing. We've got over 220 employees at our headquarters as well as our branches. Now, as far as our branches go, you can see those red stars. We have service centers all over the country. And this is where we carry parts inventory. We'll do scheduling of the service of the installations that we have in those regions. We even do blower rebuilds, including what we call an advanced exchange, where we would send a blower stage out to a site. They would swap it out with what they have, and in one step, they're back up and running. So it's a very useful service that we have. The blue stars there are our Aerzen rental, and no customer really wants to rent a blower, but there may be times when they have to. And so when they have to, we are there 24/7. And it also kind of ties into the air process demo that I'm going to talk about later on in the presentation here. So, okay, so just to kind of give you a review of what we have in the to serve the water and wastewater industry, our standard PD blowers, they've been around ever since Aerzen started, basically. So, you know, over 10,000 of them in the US. It is our mainstay product. However, it is the least efficient of the other of the three offerings that we have. The second one is our low pressure screw, probably our fastest growing product, released in 2011. And as I said before, the high speed turbo, we entered that market in 2011 as well, when the industry was really starting to look heavily at energy efficiency. Since then, we introduced at WEFTEC last year, in fact, our direct drive hybrid, which is even more efficient, even greater turn down, and so it's a cutting edge product. I hate to use that, but that term, but it is more efficient than any of the other products that we have. And here's an example of that. You may not be able to see that very closely, but that orange line is turbo performance. And a lot of people use turbo performance sort of as the baseline for high energy efficiency. But if you look at this is the total power over the course of the flow at a given set of conditions, including pressure. But in this case, the direct drive hybrid and the belt drive hybrid, both they use less power than the turbo, and the concept of turn down, which is basically the ability of a blower to go from its design flow to the minimum, is even greater. So it's a great product, and we're really looking forward to getting this into the market. Anyway, let's look at aeration controls. Now, you buy efficient blowers, energy efficient blowers, and the best way to apply them is, also along the lines of as efficiently as possible. The issue is that most traditional aeration controls are pressure-based controls, which historically has been sort of the case in terms of the how these blowers are sequenced and how the blowers respond to changes in dissolved oxygen in the basins. The pressure-based control is a series of cascading loops. So you see those little arrows down there. I'm going to back that up just for a second here. Every zone of aeration has its own dissolved oxygen probe, and then that dissolved oxygen probe also controls the valve that's letting the air into that zone. So each one of them operates independently, and then the net effect on the blower header in terms of what the pressure, whether it's high or low, that determines whether or not the blowers produce more air or less air. And the problem with that is, and if you could see on that graphic there, you're operating, that pressure point is so much higher than what the system curve is like. That system curve is that curved line along the bottom of that grade area. So you're actually operating anywhere from 1 to 1.5 psi higher than what the system's designed for. And that higher pressure results in more energy use. And if you're using centrifugal blowers like high-speed turbo, that higher pressure puts it higher on the turbo curve. And you also run the risk of putting those blowers into surge condition, which is an unsafe operating condition. So, but the problem is this is what traditionally has been sort of the mode of control. The improved level of control is what we call most open valve control. Most open valve is the idea that with all of those zones of aeration in there, each one of those will measure the dissolved oxygen, and it will send that signal back to the master control panel. And the master control panel will say, oh, okay, the dissolved oxygen level in zone 1 is this, and it needs this much air, and so on for every other zone. And then it will increase the flow on those blowers to satisfy that demand. But where the most open valve comes into play is that it's still feeding into a header, but the zone that needs the most air has its valve open the most, which is where that whole most open valve thing comes in. You're still feathering the other valves, but the net effect is that the pressure in that header is a whole lot lower. So it's getting closer. You see the yellow highlight that I have there. So you're getting closer to that system curve rather than feeding the air into a system with excess pressure. So again, if it's working with turbo blowers, you have less of a chance of getting into that surge point. So it ends up being a much more energy efficient way of applying the blowers. The next thing is controlling the rate of change, meaning how quickly or how slowly those individual valves open or close. And the traditional method has always been PID control. That term has been thrown around. It means proportional integral derivative, but the idea is that it is designed around linear responses, and a wastewater plant is anything but linear. Between the changes of low load versus high load, the BOD loading that can vary, the diurnal flows, seasonal changes, all of those add variables into the system to make that overall system really nonlinear. And even a butterfly valve, if you look at that curve down there, it's kind of got a parabolic shape to it because it's not linear. You're closing that thing off, and you really only get throttling when you're at like 60-70% close. So anyway, all that to add up to, it really is a nonlinear system. And what ends up happening is that a wastewater treatment plant will keep that in control by hiring on an integrator to come out and retune the system. So what we have to offer is a self-tuning algorithm that basically takes the place of an integrator that allows the system to kind of learn the process, and the savings that we've seen versus manual control is 41%, which is wild. or 20% versus PID control. So the next couple slides will just kind of show you what happens, how we would work with a capital project in terms of sequencing the blowers, having the DO sensors and different zones of aeration and all that. Every system is going to be unique, but this is how we address the aeration needs in that system. So who would be the potential customers for a demonstration of this? It's typically a wastewater treatment plant with aging infrastructure or very inefficient blowers like multi-stage centrifugals or two load positive displacement blowers, or systems that have little to no control and they're over aerating. I mean, so, some of these smaller plants, they might not even, again, as I said before, they might not even realize how much money they're just spending. And it can be half of the electric bill of that plant to power up those blowers. So the size of plant that we're talking about is anywhere from 500,000 gallons a day to 10 million gallons a day. And typically that's also a small community that may not always have the resources to fund a capital equipment project. And what we are offering here is a way to demonstrate, not pilot, but demonstrate how the use of energy efficient blowers and improved controls can help that plant. So it comes down to an evaluation of the existing technology and looking, getting all of the data that surrounds how they run that plant. And if they're running at those high DO levels, you can see that getting down to 2 milligrams per liter, I mean, depending on where they're running, it could be, they could save 7% or they could save 50%. So it really comes down to understanding how they're running. So we get their power bills and we would look at like what is it like a year ago and use that as sort of the basis of comparison and then help them look for funding opportunities. So again, the aeration power is half of their electric bill. So we determine the savings by looking at all of this data. And the data would be the process data, including what the maximum is and what their mixing low levels are, how efficient their blowers are, where they're running their dissolved oxygen levels, and what their power bills are. So this becomes a very effective way of measuring what we have right now as the starting point. So what we'll do is we will run the plant. We will turn off, or the plant will turn off their existing blowers. They will rent one of our high efficiency hybrid blowers, the low pressure screw. We would install DO probes if they don't have them, and we would run the system for 1 to 2 months. And typically what we would use is either one of our belt drive hybrids or one of our turbos, depending on the size of the plant. And so this is what it would look like. We'd have a rental right at the plant, hook it up with all the temporary piping, which Aerzen Rental will provide, and then we will provide that demonstration panel. And so we run the system, and there's the picture with the turbo. So we'd run that system for 1 to 2 months. I mean, this is an actual curve that shows the set point or the actual dissolved oxygen level before and after we started the control. So it's a powerful graphic that shows the before and after. So after that, when we demonstrate it, then we give the municipality options, see what grants are available, what local funding, even subsidizing the capital purchase with the savings that they saw from the actual demonstration, or a combination of all of those. And we had a site in Pennsylvania where they saved 25% on their power bill, their overall power bill, and they applied a certain amount of the rental to that cost. They also got a rebate check from the local power company. So this is something that we can do, that we have experience with, and we can help these communities that might not even know how much money they could be saving and how much more efficiently their system can operate. So it's low risk. It is not a pilot, because it's actually running the plant, and it's easy way to justify the capital improvement project. And we have experience with funding options as well. So that's pretty much it. I mean, it's very exciting. We are looking forward to working with these individual wastewater plants, either separate or in conjunction with whatever consulting engineer that they might hire. You know, we're happy to provide these services, and we're happy to also, you know, supplement these services if they happen to hire a consulting engineer. So it's become a great tool, and we look forward to working with whoever wants to have us look at their system. And there's my contact information right there. So thank you very much for your attention.
Thank you, Tom. As always, wonderful information in there. Very entertaining, but also informative. So thank you very much for that presentation.